Another type of chart or graph that can be used, in this case, is just a summary chart. You pick a certain period of time. It shows you the total kilowatt hours of that period of time comparing 3 different meters. It'll show it to you on a bar graph, or maybe you can choose different types of charts or graphs to show it on. But then it also shows you the maximum demand, the minimum demand, and the average, and it also provides you a load factor. Load factor is your average demand reading, or average kW, divided by your maximum demand for that period of time. So now what I want you to do is think about your own load shape. Think about what your building does and try to draw what's going on in your building. In this example here, this building, the outdoor lighting turns off between 4:30 and 5 o'clock in the morning, showing this little dip in usage. Around 5 o'clock, the building starts coming on. My guess in this facility is people start coming in, turning the lights on. And then just before 8 o'clock, the main heating and ventilation and the rest of the lighting in the building starts up. So that's when the building is mostly occupied. And then from around 9 to 6 o'clock at night, the building's operating at full capacity. And then 6 o'clock in the evening, things start getting shut off. Everything is mostly off at 8 o'clock at night. Outdoor lighting comes back on. That could be parking lot lights or exterior building lighting. Maintaining your base load until the next morning. So thinking about what your building does, I don't expect you to know exactly what your demand levels are, but try to think about what your building does and draw your own load shape. Let's look at another example of a load shape. And so in this case, you want to compare your load shape to your actual load shape for your facility. So let's do it for this building here. Now again, this is a number of days laid over the top of each other, and we need to identify what's going on at this facility. So we're going to look at some of the patterns. So I'm going to draw on here what the average load shape looks like for most days. So this is probably your typical weekday. But let's look at some things that kind of are standing out. These here are typical Sundays. So what's running on Sundays? What things are turning on a Sunday at this facility? How about Saturdays? Is this what's expected to happen on this Saturday? This is a number of Saturdays here, and is this usage what you would expect to see for your facility? Notice a couple days here, something ran all night long. Normally your base load goes down between 70 and 80 kW, where here it stayed up at 100 kW and didn't shut off. Is a program in your heating and ventilation system or your building control system overridden to make that happen? Another thing is what comes on at 1 o'clock in the morning. You can see between 1 and 2 o'clock in the morning, the load jumps up and runs and then comes back down again. Why does it take so long to drop off here? It drops off at 4 o'clock substantially and takes a long period of time before everything gets shut off. If this were a school or an office building, it could be janitorial workers. It also could be a retail store where the majority of things are turned off and people are going home, but there's stocking crews there at night loading merchandise back onto the shelves. So initially you thought interval data was going to help you solve your problems or answer questions for you. And now you're finding out that you still have a lot of things to find out about what interval data is trying to tell you. So let's talk about documentation now. Once you start collecting your interval data and can show it on charts and graphs, there's a lot of things that you have to keep track of. Make sure you track when you've made major changes, such as when you're doing a lighting retrofit, or when you make changes to your heating and ventilation system. How about when you're adding new equipment, or you've removed a bunch of equipment? Also, think about occupancy changes. If you've added a lot of new employees, added more space for customers, those types of things are going to make a difference in your energy use. One way to track those is on a schedule like this. This is called an equipment checklist, where you can document the operating schedules. In this case here, you would check that this is a first review. You want to make sure you note the date and time and try to list the different equipment types that you have, what size they are, and when you expect them to come on during each day of the week, and what type of control is here. Is it controlled by timers? Is it manually done? Down in the other section down here is a great place to put when people come in. For example, a retail store, when the doors open for business. That'll help determine what your load profile looks like as well. Once you do this for your first review and you take a look at your load profiles, you'll start getting some answers to some of your questions. As you make some simple changes to your systems to make your load shape look more in line with what should be happening in your building, make sure you do this equipment check again and make a note of when it was done and what changes might have occurred. This is the end of Interpreting Electric Meter Data, session number 4. What do you do with the interval data once you get it? If you haven't already, please go to the Better Bricks website and go through the other 4 parts of this training.